turn on the face cam. All right, let's get started. Let's do this again. All right. So I'm gonna dive into some content here. Today is slightly different. We usually have Labor Day during this week during the fall semester. In the spring, we kind of lose a day because it starts on a Wednesday now. So today we do have a little bit of flex time, which I intend to use to start going over the first programming task, and I'll get a little bit ahead. I'll do a little bit of unit testing, but really after we cover the data structures, which took an hour and 20 minutes last time, so about halfway through the lecture, we'll prepare you for task one and cover a lot of things that are usually covered in lab, which we don't have lab in the summer, so I'll be able to fill that in with some stuff that we can't fit in just strictly lecture. So let's do data structures. I'm going to continue my strategy where... Oh, I got to turn this down a little. I got to continue this. I'm going to continue the strategy where I do live coding and live memory diagrams in this lecture, and in the 8 a.m. I'll do purely the slides. So the slides that you see here, these are covered in the 8 a.m. If you prefer that style, you can watch that VOD or wake up at 8 a.m. or whatever time zone you're in, whatever time that is for you, and watch that one live. Or if you prefer this style, you can watch this lecture. Again, I don't care which lecture you go to, depending on your registration. That's fine. And I said I'd dive right into it, but I always have a few things I want to say at the top. I was playing with the audio a bit. The morning lecture, I don't know. I swear I don't change any settings on this mic at all, but sometimes it just decides that it's going to be really crappy. I played with it between lectures. I think I got it, but if I got the quality better. But if the audio level itself is off, if it's too loud or too quiet, it looks like it might be either perfect or a little too loud right now. So just let me know, and I'll adjust. Let me know in chat, and we can adjust that. So with that, even though we're doing live coding in this lecture, there are some slides. I have some conceptual slides that we have to cover, or rather that I want to cover that I think will be useful for your understanding. Audio is 100% better. Awesome. Those are my test videos. Downloads. I didn't have to close that. And 2.1. So there are a few slides of conceptual content that I want to go over. Oh, I gotta go back to the top. Why does it? It did that to me last time too. Why doesn't it, when I reopen the file, go back to the beginning of the file? Okay, so a few concept slides, and then we'll go to IntelliJ and do our live coding stuff. All right, so I want to talk about memory. This should be a bit of review in 115, but I'm not sure. Someday I'll check, and of course there's a bunch of different instructors. They probably each do it slightly different, but I'm not sure if they cover the idea behind memory in 115, and I can't assume that you've all taken 115 here with memory diagrams anyway, so if you're a transfer student, I still want to take everything from the top regardless. But for a lot of you, hopefully this is review, but whatever. It's a few slides. It's probably good to get a reminder of this anyway, of what memory even is. We talk about memory, these traces, these memory diagrams, the stack and the heap. Well, we talk about this all the time, so I want to zoom out a little bit and talk about what this even is. And when we say memory, we mean random access memory, RAM. Whatever device you're using, whenever you buy a device, one of the big specs that you look at is the amount of RAM, or sometimes we just straight up call it memory, that device has. These days you probably have at least 16, you might have 8 still, 16, 32, 64 even gigs of RAM. And what that means is that's how much memory you have for the execution of all the programs on your device. And looks like this, these RAM sticks, you have these in your device. Maybe you probably, if you have a laptop, you have the smaller version. This is desktop RAM. And, excuse me. And what this is effectively one giant array of bytes. This is one big array of memory where you can store all kinds of different values. Anything that can be stored in binary, which is everything in a computer, is going to be stored in memory. or can be stored in memory. And the memory addresses are indexed just like an array. So when we have our memory addresses, which we didn't see on Tuesday, but we'll start seeing today, and you've seen in 115 if you've done memory diagrams in 115, then the memory address is effectively an index in this giant array. So you have an array, if you have 16 gigs of RAM, you have about 16 billion indices in this array where you can store all of your memory for your running programs. And when your program does start, the first thing your program has to do is go to the operating system and ask for some memory. It's going to say, hey, I'm going to start running. I've got this program, this beautiful code I'm going to run. I need some memory. Operating system, give me a slice of that RAM so I can run my program. And now this is a little abstracted. Like this semester, we're using Java. So our program is going to ask the JVM. The JVM is going to allocate us memory, and the JVM goes to the operating system when it starts to ask for memory. So there's a little bit of abstraction there. But at whether it goes through an intermediary or not, whatever program you ever run does have to somehow get memory from the operating system. The operating system is what controls memory usage. So we go to the operating system, we say, give me a slice of memory, and we get some portion of that RAM stick. We get some portion of memory that we're allowed to use for our program that we can't break out of. Anything before that chunk of memory might be used by another program, and everything after might be used by another program. But we have this one chunk that's allocated for the execution of our program, and that's what we call stack memory. So that's our stack. It's one continuous block of memory addresses, and it will be continuous block of memory. It will be continuous as in like indices, 5 billion to 5 billion and 3,000. I'm just making the numbers up, of course, but it will be one block of memory with continuous memory addresses. And this stack will follow a first in, first out. There's one thing I want to say. So everything will be on the RAM sticks, except when we get to file I/O. File I/O is when we go to the actual disk itself, when we're saving and reading files. That's when we go to our hard drive. Everything else is going to be in RAM. Everything else is in RAM. So, and this follows a last in, first out structure, and the stack really is a stack of stack frames. So we have a stack of stack frames, and it follows this last in, first out in the sense that when you start your program, you have the main method. The main method stack frame is on the bottom of the stack, and then whenever you call a method, you're going to add a new method call, a new stack frame to the top of the stack. You might add that method, might call another method, might call another method. So you have a stack of stack frames. New stack frames can only be added to the top of the stack. And whenever a stack frame returns, it's going to remove that stack frame from the top of the stack. And whatever was below it is now the new top of the stack. And only the stack frame at the top of the stack is the active stack frame. That's the only one that you can actually access the variables of. Like each stack frame is an isolated environment, and the stack frame that's on the top of the stack, the variables in that stack frame are the only ones that are, as we say, in scope. They're the only ones that you can access until that stack frame either creates another stack frame or returns and goes back to the previous stack frame. And of course, in our memory diagrams, we draw things upside down. So the main stack frame is at the top visually, and then we add new stack frames lower visually in our memory diagrams. But we do think of it conceptually as a stack where the top of the stack is at the bottom visually in our diagrams. And there's reasons for that. You'll talk about them in 220, I'm sure. The short answer why we draw them upside down is because that's more accurate to how it works in the actual computer. It more accurately represents actual execution of programs. Which brings us to heap space. So again, if you took 115 here, you saw a little bit of heap space. We'll see it to that same extent today. We're still in the reviewing 115, but in Java content right now. Heap space is going to be a much, much bigger topic throughout this semester, starting on Thursday, next Thursday, a week from today. Heap memory is going to be a big, big player all semester. For now, we're just going to see array lists and hash maps, which are like our Python lists and dictionaries. These are the two dash structures that you've already seen. These are the Java versions of those. These are the first things that are going to go in the heap. But what is the heap? So we get the stack. That's what we get when we start our program. And the heap is where we get space allocated if we need more space during the execution of our program. So our program's running and we're happy with the stack space for a while, but eventually we get to a point where we're like, oh crap, we need more space. And more importantly, we need dynamic space. That's when we're going to go over to the heap. And what we do is we ask the operating system for more memory in addition to our stack space. We say we need more memory because there's this thing that we're going to do that we just need some dynamic, flexible memory. And then it'll allocate that memory to us. Somewhere in RAM, it's going to find enough space that we're asking for and then give us access to that memory and prevent any other program from accessing that memory. So it gives us that memory by giving us a reference, which is the memory address, which is the index on this giant array. It's going to give us that reference to the first byte of memory in that memory that was allocated to us and say, here is your heap space. Do whatever you're going to do with it. And this is important especially when we get to data structures, but it's going to be important for all of our objects moving forward. We're going to need to use heap space because it's more dynamic. So for example, if we have an array list, and say we have some variable x that we put in this place in memory, and then our array list is going to take up, say, this much memory. Say we have an array list. I'm going to assume it's an array list of bytes. That's going to take up 4 bytes, and we have some variable that's just 1 byte. Just for the sake of example, usually they'd be like doubles that'll take 8 bytes each, but just so the diagram's easier. We have an array list that takes up 4 bytes. We have 4 values in this array list. And then we have some other variable y that we put right here. And the stack will be a continuous block of memory. When I say that, I actually mean like if there's one value here, the next value is going to be here, the next value is going to be here. We can't have any gaps in the stack. We can't just leave some empty space in the stack. Everything will be continuous. So we have x, our array, and then y. And then what happens if we want to add another value to our array? We need the array to be a continuous block of memory based on how arrays work or array lists work, but the place where we would put that 5th value is already taken by the variable y. There's already a value there. That memory address is already being used, so we can't add that 5th element to the array. We just can't do it. So we need some other solutions. There's all kinds of things we could dream up of how to address this problem. And the answer that our programs use is heap space. So instead of putting those values on the stack directly, we're going to create that array list on the heap, which is somewhere in memory. It could be anywhere in memory. It's wherever the operating system decided it had some space to give us. But the important thing is it's not in the stack. So the stack we get when we start our program, the heap is wherever the operating system gave us memory at that point in time. And in fact, if we have 2 objects on the heap in the same program, both of those objects might be in completely different places in memory. So if we have 2 objects on the heap and also our stack, we have 3 different locations in memory that our program is using at that current time, at that time in execution. So the heap is somewhere other than the stack. We don't know where that is, and we don't care where it is. We actually don't care. As long as we're able to access that memory, I don't actually care. I have never cared while I'm running a program I've never cared like where on my RAM stick my values are. I just don't care. Maybe you do. I don't know. I doubt it. But we do care that we can access those values, and that's where we're going to be talking about references to objects on the heap. That's going to be a conversation throughout this whole semester. With the exception of next Tuesday, we'll be talking about unit testing. And then after that, we go right back to lots of memory stuff, and references will come up constantly. So we only store references to objects on the heap. Okay, and here's where I'm going to get into live coding. Let's do this. Oops, not that one. Actually, I want this one gone. We'll recreate all that code later in this, later today, but not yet. And I had this, I never fixed this in the other lecture. I meant to just to show how to fix things. So sometimes you'll get issues like this. OpenJDK 19 is missing. If we go to configure, we should be able to choose our latest JDK, whatever we downloaded. 22 we downloaded last time. And that may or may not get rid of the issue. If it doesn't, go to File, Project Structure. And my problem is in my SDKs, if you go to SDKs, I have two SDKs. I have Java 19 and Java 22. Most of you shouldn't ever have this issue. I have this because I've had IntelliJ installed forever, and I just keep downloading the next JDK. So JDK 19, I'm going to remove it. Now I only have JDK 22. Now I don't have any JDK defined because my project was linked to 19. Now I do set up JDK, click 22, and that should go away. And all my errors went away. JDK 19 is missing. Yeah, I know. I believe that fixed the issue, but I want to get rid of that banner as well. Yeah, my program ran just fine. But I want to get rid of that banner, so let me do just a little bit more here. Let me go to project 22, 20. All this looks good. And then it's going to be in my pom.xml. No, that says 20. I'm going to update this just anyway. Change this to 22. Oh, maybe it was a fake error, or maybe change that to 22 worked. Anyway, I got rid of it. Array list example, delete. Hashmap example, delete. Okay, those are the two programs that we want to write today. Get rid of this. Move this, and I'll eventually get rid of it. New class. Can you show how to download the GitHub if you have time? I do plan on doing that later this lecture. I'll give you the very brief version of it right now. Assuming you mean clone the project code, the starter code, you go to Git, clone, and paste that link. Actually, I'll do a little bit longer one. Assuming you mean clone the project, go to the repo for the project, go to code, and copy this link. Then go to Git, clone, and paste that link right here, and then clone, and that'll give you the starter code for the project. If you're on a Windows machine, you might, I think this is still the case, you might have to download and install Git also. So go to the internet, do install Git, and install Git onto your device before you can use Git. Okay. That's a brief one. If you want more explanation, when we get to that part in lecture, I'll be happy to answer all kinds of questions. Okay, so array list example. So we want to write code that's going to use an array list. Let's start with a main method and use an array list class. So again, this is like our list in Python. If you've used JavaScript, it's been a while since we had JavaScript in 1.15, but it'd be your array in JavaScript. It's an array in most classes. It's vector in C++ if you've used C++. But it's your typical what am I thinking? Your typical sequential data structure where all your values are sequential in memory, meaning that it's one continuous block, like I was saying when we were in the slides. And the values are indexed by integers starting at 0, no matter what language you're coming from, unless you're coming from MATLAB where they're indexed at 1. Should be familiar to you no matter how you got to 116. It's that data structure. It's the basic first data structure you learn in any language that you've came from. So we want to create a variable of type ArrayList. And let me just get some code. Let me get some code on here first. New ArrayList. Just because the first thing I want to talk about is going to be one of the last things that pops up there. So this auto-imported, IntelliJ will do this often for you. It'll automatically add your import statements. You usually want to double check them to make sure you imported the right thing. There are some cases, sometimes in office hours, I'll see a student had the wrong import, and it's because they let the IDE do a little too much for them. They let IntelliJ just fix their errors, but it actually created more errors. But this is the first thing I want to talk about. Before we use an array list, we do have to import it. When we use a class that's in a different package than the code we're writing, we have to import it. There are some exceptions to this. For example, string we know is a class, but this one is automatically imported whenever we have a Java program. Every Java program ever has string imported, and we don't have to manually import string. It's basic enough that Java says, you know what, everybody needs this. We're not going to make everybody import it. Same with system. System is auto-imported. Integer, I didn't have to import integer, which I'll talk about in a second. Certain classes don't need to be imported. ArrayList is our first class that does need to be explicitly imported. Even though ArrayList does come with Java, it's packaged with Java, we do have to import it explicitly. When we import, we're going to use the fully qualified name of that class, meaning the package name and the class name. So the ArrayList class can be found in a package Java util, meaning we can find it in a directory named Java with a subdirectory util, and in a file named arraylist.java. And since I'm in IntelliJ, I'm going to take you right there. Whenever you have code and you want to see the source code of anything that you're using, if you hold Control-click or Command-click, whether you're on Windows or Mac, and click on that name, it'll take you to its source code. So this will take me right to the ArrayList class, and if you're interested, you can look through all of the goodness inside the ArrayList class. There's lots and lots of stuff. This is over 1,000 lines, mostly comments for what it's worth, of code to define what an ArrayList is and does. So if you're ever interested in exactly what an ArrayList is, or any object any class that you're using, you can always go to the source code and see all the source of Java itself, of the Java standard library. And what I want to point out right now, package Java util. The class is ArrayList. And if I look at my directory structure inside JDK22, I have a package named Java, a subpackage named util, and a file named arraylist.java. It doesn't show the .java here, but that's where I can find the ArrayList class. Just like we would expect when we say import Java util ArrayList, it's exactly where we can find the ArrayList class. So it exactly matches what we're doing in our... Let me clean up some of this stuff. So that'll do exactly what we expect, like we talked about on Tuesday, where the package, this is in a package week 2, and a file named ArrayList example.java. Same exact thing that we expect from that. And then to create a new array list, we use the keyword new. New array list, angle brackets, and then parentheses. Let's talk about each piece of this. First, new. New is what we're going to use whenever we want to create a new object on the heap. Whenever you see new, you should think There's a new object that's going to appear on the heap right now. New is how we create new objects on the heap. If you see the keyword new, there's a new object that's about to have to be put on the heap. If you do not see the keyword new, there will not be a new object added to the heap. Let me move this over too. There will not be a new object added to the heap. That'll be very important when you're doing your memory diagrams. It's one of your sanity checks that you can use. And when we get to the memory diagram, I'll say this again. But look through your code after you're done with the memory diagram. Look through your code. Look for how many times the keyword new was hit. That's how many objects you should have on the heap. If those two numbers are different, you have something wrong and you're going to fail that quiz. So review your work, see where you made your mistake, and double check that before handing in your quiz. If the number of objects on your memory diagram in the heap don't match the number of times the keyword aligned with the keyword new was executed. Okay, next is these angle brackets. I'm not going to worry about this too much until we get to the other side here. That's where I'll talk about it. These angle brackets can pretty much always be empty when you're creating a new data structure like this. For what it's worth, we can, just like we have on the left-hand side, we can put integer here. Oops, if I spell it right. We can put integer here, and that's the same exact code. It does the same exact thing. The only difference is my IDE is going to say, hey, you don't have to do that, you know. And it's going to recommend that I don't put integer there. This is one of the few times where Java helps us out. It'll look to the left-hand side and see that it's going to be an array list of integers and assume that I mean integer here without forcing me to type it. When we use the keyword new, what we're actually doing is calling a special method called a constructor. We're calling a constructor method. I have a lot to talk about on next Thursday about constructors, where we're going to write our own constructors for our own classes. For now, I just want to point out that that is a method call. When you say new and then something, we are calling a method that will create the new object. And method calls need argument lists, so we do have to have our parentheses. This is an empty argument list for this method call. Just like if we were calling... what methods have we seen yet? We haven't really seen anything. But we'll see if we're calling like .size on this thing, it's the same thing as that, a method that takes no arguments. And you can already see that this is much more complicated than in Python. In Python, you would just do this without a semicolon. Java is a lot more verbose. A lot of that is because it's strongly typed. And strongly typed is a very nice feature, as it turns out. You probably won't appreciate it even by the end of this semester. But strong typing is such a nice thing that it is worth the extra verbosity here. Is that the right word? Verbosity? Doesn't sound like a real word. Verboseness. And then on the left-hand side of the equal sign, we have the variable name, the variable that we're going to store this array list in, the variable in which we're going to store this array list. And every variable needs a type in Java. So the variable's type is going to be array list. We know that much. But there's a little extra we need here. We need these angle brackets, and here's where I want to talk about it. So array list is the type, sure. But we can't just say array list. For what it's worth, we can. Like this code compiles, but we get a warning because we should never do that. We have to specify the type of the array list. So that we don't just create an array list, we create an array list of integers. And why do we type integer instead of int? Excellent question. And there is a good answer to that. Array list of integer is what we do. So this array list can only ever store integers for its entire lifetime. We can't put doubles, strings, we can't put anything else in this. Something we took for granted in Python was that we could mix types in our data structures. We cannot do that in Java. Java is strongly typed. We create an array list of integers and can only ever store integers. So why integer and not int? If I do int, the really short answer, I have a very long answer for this one, but the very short answer is I can't use int. That's not going to compile. I'm not going to be able to run this code. I'll get all kinds of errors. I got the red squiggles. That means this ain't going to compile. And we get, can't do it. Required reference found int. Can't do it. So in these angle brackets, this is called our type parameter list. In Java, it's called generics, but I don't know. I don't like that term. I'll use type parameter because that's what it's called in other languages. Our type parameter list, we have to give our array list a type parameter to say what type it is, and we do that in this angle bracket parameter list, or argument list in this case, because we're on the other side of things. This list can only be class types. We cannot use primitives as type parameters. So I want to create an array list of int, but I can't do that. As much as I want to, I can't do that. I just am not allowed to do that. Java won't let me. We have to have some object, some class type, some type that's created by classes. And luckily, Java does give us an out for this. It says, well, don't worry, I give you a class type for each primitive type. So integer, I also have capital D double, capital B Boolean. I have these different class types that match each primitive, and Java's pretty good about mixing and matching these. So if I have int x equals 7, integer y equals x, x equals y, I can go the other way around. Java's really good at automatically converting between the two. It's going to give me warnings because it's dumb that I did that, but it's going to say convert to primitive. I like that it does that, actually. I've never tried that before. That it says, hey, this is dumb, why are you doing this? But when it's a type parameter, it has to be the class type, and anywhere else, and Java's going to mix and match between them. So even though this is integer, anytime I work with this array list, I'm going to use int everywhere, all over the place. In the context of CSE116, I will always use the primitive types, lowercase I int, lowercase d double, lowercase b boolean. I will always, always, always use them, the primitive types, unless I have to use the class type. And the class type, I only have to use those if it's a type parameter in a data structure, or a type parameter anywhere. We use type parameters for comparators too, so I can't say only data structures. But whenever it's a type parameter, that's the only time I'm ever going to use the class types for my primitives. This is very important, and some of you will have this. Actually, none of you will probably have this issue if you're hearing my voice, but the students who skip lecture and think they're just going to blast into the homeworks, they'll have this issue. So I'm giving this disclaimer just so I know that they didn't watch lecture, because I'm going to give this disclaimer right now. I will always use the primitive types unless I have to use the class type, which is only type parameters. So if you ever have a method that returns the capital I integer, capital D double, capital B Boolean, if you ever write a method that returns that or takes that as a parameter, that is wrong. It will cause errors in Autolab. I wish it did. This is one case. Let me back up a little bit. So Java's good at converting between like int and integer. That's called autoboxing. And it's usually good about that, except when it's a return type in Autolab, specifically the way your code is compiled in Autolab. It will cause issues in Autolab if you submit and you have the wrong type. Always use the primitive types unless they're type parameters in the confines of 116. Out there in your future career, maybe you work for a shop that likes to use the class types everywhere, whatever, that's fine, I don't care. In the confines of 116, I had to choose one or the other, and I chose primitives. We're going to use primitives for those. So if you have a return type, and I think this comes up in sum of digits, right in task 1. If sum of digits returns, or average, I think it comes up in average, the very first method of the entire class. If you have your average method return a capital D double instead of a lowercase d double, that's not going to work in Autolab. And in the homework handout, it'll say lowercase d double. It says double, or the worst is when it's int versus integer, because they're completely different words. In the homework handout for sum of digits, it'll say return an int, lowercase I int. And I always wonder what's going through someone's mind when they look at the homework doc. You're looking at the homework doc, and that's informing you of what to code. When you see lowercase int and instead you hold shift, hit I, hit NTEGER, and type out the whole integer involving the shift key and everything. Like, why did you do all that extra work and completely ignore what you just read in the homework document? I don't understand it, but every semester there's a handful of students who do that. And I don't know why, but I have my guesses. My best guess is that they did not write their own code. I'll let you fill in the blanks of who wrote that code or what wrote that code for them. And that's the assumption I'm going to move forward with during that office hour interaction, and it's usually not pleasant. Don't make that mistake. I spend this much time in lecture talking about it. There's no way anyone can watch lecture and make that mistake. And even if you don't watch lecture and you're reading the homework document, you're not going to make that mistake. So I don't see any reason for that one. So none of you are going to make that mistake if you're hearing my voice, hearing me say that. Which means if you have that mistake and someone who makes that mistake in office hours, I'm going to assume they have not been watching lecture and are really not trying and probably want to fail. But rather, I shouldn't word it like that. They don't want to learn. I'll say that much. Add IntelliJ setup in the spring semester, although now when I log in it says I have no activation. Your educational license expires every year, but you can auto-renew it the same way that you got your license to begin with. You can renew that license. I'm assuming you did IntelliJ Ultimate with your educational license. That's when you would get this error. You can go on the website, renew your license. It takes a minute or two, but you can renew your license and get that activation back. If you don't want to deal with that, you can always download IntelliJ Community, and that's free for everybody. That you can use that without having to do your educational license. But educational license, I do recommend doing that and getting an IntelliJ Ultimate. Even if you don't use the new features, the advanced features in 116, you might want them sometime in the future. So it doesn't hurt to have them. You get it for free because your email address ends in .edu. So you can get your educational license for free. There's no reason not to, really. Unless you don't want to take the extra steps. Community will be fine for the course. It'll do everything you need it to do. Okay, so with all that, we got type parameters. I gave my rant about never use these unless they're type parameters. Always use int and lowercase d double, lowercase b boolean, etc. So let's start using this array list. So with this array list, I'm going to use a quick loop here for I equals 0. I'll try to make this as close as I can remember to the slides. I equals 0, I less than 4, I plus plus. My array, and here's our first, oops, I hit cap locks. Here's my first case, our first case of calling a method on an array list. So in Python, you would say like, actually you do append or push. I always forget which one is Python, which one's JavaScript. Or you could do, I believe you can use this syntax, equals 10 minus I. Yeah, I believe you can do this in Python. You cannot do any of that in Java. In Java, it's add. .add, and then whatever value you want to add. And even though I is an int, and I'm going to do int stuff here, 10 minus I is what I want to go with because that's what it is in the slides. I think I did X instead of I, but I'm going to switch it up, at least a minor amount. I'm going to add this, which is going to be an int, to an array list of integer. This is a case where Java will autobox. It will automatically convert that int to an integer for me, and everything will work fine. So anywhere except literally where you specify the type parameter, it's going to be int. All the other places it's going to be int. I don't have to worry about this being integer because this is integer. Just use int everywhere except when you're declaring your variables that take type parameters. Is the only case where you're going to do something different. Okay, so that adds things to the array list. And then I want to do something again. I feel like I repeat this way too much, but something that you should have seen in 115, but just in case, integer. My array, actually let's name this a little different. Another array equals my array. So I'm going to assign my array to another array, and I'm actually not going to say anything about that right now. Let me get some more of the code and just explain the Java syntax. This will be assigned by reference. That's my punchline for that. But I'll save it for the memory diagram so we can see the visual of exactly what's happening. But another array and my array are both going to refer to the same array. I'm going to do something I don't do in the slides. Another array dot add -15. So that's going to add another value to this array. I'm going to print my array, and then I want a sum method. Oh my. Public static int sum is going to take an array list of integer and return the sum of all the values. I'm just going to stub this out for now so I can finish my main method, and then we'll finish the sum method. But I want to return the sum of all the ints in that array list, the input array list. And notice that sum is going to return an int. I don't care that this is integer. I'm always going to use int unless it is a type parameter. So I'm still going to return an int. If this is integer with a capital I, it's not going to work in Autolab. You're going to get errors, and you're going to have to hear me say, my whole rant about that again. And I'm going to say, do you go to lecture? Where did you write this code? Why did you write that? And nobody ever has good answers for those questions for that specific situation. But if it was an innocent mistake, explain to me how you made that mistake, and I would like to learn. I would like to learn why that mistake happens. Because if it is something else, just nobody's ever given me a good reason for why they typed the wrong one. And if you can't explain why you typed the code that you did, I gotta assume you didn't type it. But if you have a good reason, I'd like to hear them. So I want int, again, I'm always going to use lowercase I int unless I have to use the type parameter, unless it's a type parameter. Int, let's call this result equals sum of my array. And let's just print result to the screen. Okay, let's write our sum method. So now we have to iterate over the values of this array list and keep track of the running total. So total seems like a good variable name for that. Total. And this better seem familiar. This is going to be the accumulator pattern. I initialize my accumulator variable. I loop over the array list. So for int I equals 0, I less than input.size, I plus plus. This is going to iterate over all of the indices of my array, and I'm using strictly less than. So when I is equal to input.size, I'm not going to access the value at that index because that would be out of bounds. But this will go from 0 to size -1, which is exactly what I want. And then total plus equals input.get. Get is how we're going to access a value. We can't use the array notation. We have to use .get. And then the value at index I is going to give me whatever value is at index I. Let's run this thing. See what we get. Should be some negative value. It's not a negative value. Oh yeah, because I did 10 minus. Right. Never mind. Yeah, it's 10 minus, so it's not going to be negative. But we get the sum of these values, which should be 19. Yeah, 8 and 7 is 15. Minus 15, those wipe out, and then just 19. Okay, so that's our array list example. Now we head over to the tracing tool. I'm really not logged in. Didn't I just log in last lecture? How am I logged out? Yeah, and I just did, okay. Practice. We're gonna get better at this stuff. This I don't have to resize like crazy as it turns out. But I have to get the right pixel. Okay. Let's zoom a little bit. We do need the heap this time, but we only need 2 IO lines. Let me make this just a little smaller. Let me not put it in front of my face. Oh, I'm zoomed in on the page itself too. Let's put it right. Oh, there is one more thing I actually wanted to say. I'm glad you asked that question. Why is it input less than size and not input less than size minus 1? Since this is strictly less than, so the size is going to be 5. Once I is 5, it's going to be 5 less than 5 is false. So the loop never executes when I equals 5. The loop is going to execute 0, 1, 2, 3, 4. And then when it hits 5, it breaks out of the loop. So this will be executed for 0 through 4, but not 5, not when it equals the size. If I want to do minus 1, I could make this less than or equal, and then do minus 1 here. This would do the same exact thing, because once I is the same is 5 less than equal to 4 is false, then it would break out of the loop. So that would do the same thing. But we actually have another option here, which we're going to see when we talk about hashmap, is I can use Java's enhanced loop, or what I call is a for each loop, because that's what it's called in like every other language. Java had to be different. Is int. I'm going to name this something different just to avoid the confusion. Value of input is going to iterate over all the values, all the integers in this array list. And then I don't have to do input.get. I can just add the value directly. So I can use this fancy loop to iterate over the values and not have to think about the indices and risk off by 1 errors and things like that. It's a much simpler way if you just want to iterate over the values of a list and you're not interested in the indices of those values. But I'm going to go back to this one because that's what we're going to trace in the memory diagram. Because it's a little practice with for loops. And you haven't seen the style of for loop in Python, so I think it's worth messing with. I don't know exactly where to put the code. Let me put it in a way that my head's not going to block it. This should be the perfect location for that. All right, so we start with the main method. Create a stack frame main. The main method is going to create a new array. My array, and here's the first thing that we see that's different than what we did on Tuesday. Whenever we see the keyword new, we're going to create an object on the heap. If we don't see the keyword new, we're not creating an object on the heap. If we see the keyword new, we're creating an object on the heap. Makes it pretty simple in Java to know when an object is being created on the heap. So when we create this array list, we're going to create a new heap object, and where it says new heap 1, where this is here, this is going to be the type of the object. Array list, we create a new array list, that's going to be array list. And no parent, this is something that we'll start doing on Thursday, next Thursday, but we don't do anything with that now. So we create a new array list, and we note the reference that we get. We can change these. If you want to use different numbers, that's fine. I'm just going to stick with the defaults. 0x002 is going to be the memory address for this object, or what we'll refer to as its reference. So this is a reference to that object, 0x002. This is to represent the memory address of where this is being stored. And the 0x, don't get too hung up on the 0x. What that means is that this is a hex value, meaning I could have like F A, B. The A through F letters are the values 10 through 15. In hex, you don't have to worry about that really in 116, but the OX is going to mean that it's a hex value, and I will read the hex values as though they're base 10 just because it's easier, but note that they are actually hex values because we're representing memory addresses. But technically, even further, another asterisk on that, we'll just pile them on. Java doesn't give you access to the memory addresses anyway. We can't actually see the memory addresses in Java because the JVM won't tell us what they are. But we're going to pretend that we can because we want to understand what happens in memory. Okay, so with that, when we create a new array list, when we call the constructor, we create the object on the heap, and what this returns is the reference, OX002. So what's stored in my array is not an array list. My array, the variable, does not store an array list. Even though its type is array list of integer, it does not store an array list of integers. It stores a reference to an array list of integers. So the only thing that's stored in my array is OX002. That's it. What this reference is a map that tells us how to navigate RAM and how to get to the location where this array list was allocated. Because this array list just went somewhere in memory. We don't know where, we don't care where. The heap is just one big glob of memory, and each object on the heap could be in completely different locations. We don't know where this array list is. We don't care where this array list is. What's important is that we have the reference, and that the references are consistent. We have a reference which tells us how to find this array list. So we have a reference OX002 that tells us that my array has a reference which is a way to find this object on the heap. That's the only thing my array stores is that reference. How to find that array list on the heap. That's all it stores. Then we have our loop. I'll go through the loop fairly quickly here because we've already done loops. I is created as part of the for loop. So I has the value 0. And then my array.add 10 minus I is 0. I is 0 less than 4, true. My array.add, this is the part I want to focus on, is this little guy right. I got to get used to not being able to highlight things in the code like that. The click and drag is moving the whole thing. My array dot, this dot right here, that's what I want to talk about. So my array stores a memory address that stores a reference where we can find an array list on the heap. Now, I don't care about that reference. I have never in my career cared about a reference itself ever. I don't care where this array list is. I don't care to look at the map to see where that array list lives in memory. I just do not care ever. But that's the only thing that my array stores is that memory address, that location, that reference, that location in memory. That's all my array stores. What the dot operator says, that's me telling Java, hey, my array, you store a reference and I don't care. The dot means take me to the object to which you refer. So the dot operator says, your reference, my array, you resolve to the reference OX02 and I don't care. Take me to that object. You follow the map, take me over to the heap, and show me the object that you're referring to, because the object you're referring to is what I care about. That's what I'm actually after here. So my array dot means my array dot, head over to that reference on the heap and go to that object. Now, after the dot operator, anything we do after the dot operator is going to be on the heap. We're going to be at the array list now. So when we call the add method, we're calling the add method on this object in the heap. So we call add on this array list because we followed the reference using the dot operator. And we're going to add 10 minus I. 10 minus I is a new expression. It's separate from the overall expression that we're evaluating. We have to resolve the argument expression separately. So when we do 10 minus I, we resolve that back at the stack frame. So 10 minus I is 0, so this resolves to 10. And then the add method on the object gets the value 10. So we're adding 10 to this array list. And add in an array list will add to the next available index. We have nothing in this array list, so the next available index is 0. And then for the name and value for the variables in an array list, the names, we use the indices, and then value is going to be 10 for this case. We get to the end of the loop, we increment I, and now we just run through the thing a bunch more times. myArray.add 10 minus 1. So at index 1, the next available index, we're going to get the value 9. I increments to 2. I keep looking at the wrong spot. 2, create new variable, 2, 8. 3, I should have made this a few fewer steps. 7, 4, and when x is 4, the condition is false, so the loop breaks. Cross out the code block. I is no longer in memory anymore because we hit the end of the code block in which it was declared, so we can no longer access I anymore, and we get to the code after the for loop. And the first thing we do, we create another variable. Another array, and another array equals my array. Here's our next big question. How does this work? And this is why I kept repeated a few times now. Whenever we don't see the keyword new, we are not creating a new object. So the one thing we're not doing is creating a new object on the heap. We are not doing that. If we look through this code, we see the keyword new shows up one time. It's not in a loop or a method or anything, so it's only going to be hit one time total throughout the execution of this program. So even by the end of the program, we expect to only see one object on the heap. This array list is the only object that's ever going to be added to the heap. So we have an assignment here, and we have to figure out how this assignment is going to work. Another array equals my array. And this is another case where just don't overthink it. If this were two integers being assigned to each other, if I said int x equals 3, int y equals x, you wouldn't think a thing of it. You'd say x is 3, I'm going to create y gets the value 3, and just copy whatever value is in x over to y. You would copy the value over. It's not any different with references. No different at all. So another array equals my array. My array resolves to OX02. You literally, my array, the name, this is a lookup table. What's the value of my array? It's OX02. It is not an array list. It's not a copy of this array list. It's nothing except the reference. It's just the reference OX02. So when another array equals my array and my array resolves to this reference, another array just gets the reference. That's it. That's all that happens. Another array equals my array. We're not copying the array, creating a new array list. None of that. None of that ever happens. We don't see the keyword new. That definitely doesn't happen. We copy the reference. So what we end up with is two variables that both store references to the same single object. There's only one object in this whole program, but we have two variables that both refer to the same object. Now our minds, when we look at this code, we see two different variable names, and we like to think that there are two different array lists. And without seeing the memory diagram, if you're just looking at the code, it's easy to make that mistake and think that we have two array lists in this program, but we don't. When you see the memory diagram, it makes it a bit more clear that my array and another array are both referring to the same singular array list. Which means when we hit another array.add, another array, dot means follow the reference, add, we're adding -15 to this array list. So at index 4, we have -15. And then even though we added that to through the variable another array, when we print my array to the screen, my array 02 follow the reference, we're going to see that negative 15 there. Even though we like to think negative 15 was added to another array, not my array. Those are two different arrays. No, they're not. It's the same array. It's the same array because this line right here was what we call assigned by reference. We only moved a reference. We only assigned a reference. We did not assign a copy of the value of the array list. We assigned the reference only. And there's a caveat, because it's Java, it's a little different than that. We did do assign by value. Assign by value is like what you would think with most, with any primitives. With the int y equals x example, that would be assigning the value. We take the value of x and we assign that value to y. We literally copy the value and assign it over. So you would think, well, the same thing must happen here. We copy the array list. Well, no, but we did do the same thing. We copied the value, but the value is a reference. So technically it's assigned by value, but the value is a reference. That's the correct way of saying it in Java. But I'm lazy. I don't feel like saying that every time. So I'm going to say assigned by reference, even though it is assigned by value, but the value is a reference. I'm going to say assigned by reference. Then when you get to 220, your 220 instructor can say how lazy and dumb I am and how I never should have said that was assigned by reference, because it's not. And then they'll explain what assigned by reference really is, and which would be another array being assigned the reference, the memory address of the variable my array on the stack, which is a whole different thing. But that distinction will matter in 220 when you're coding in C and you have pointers and references and they behave differently. Java only has these assigned by value references, which I'm going to call just assigned by reference. Then your 220 instructor can curse me out and everything. That's fine. I'm going to call that their problem. But that's my disclaimer. So if you do care about the nuances of how that works, I did cover it, I did explain it, but I'm not going to require you to know that nuance, that very nuanced point, because you have nothing to compare it to. So it really isn't important yet in your career. And we're going to print my array. My array is going to see that negative 15. So when we print this out, and for what it's worth, here's the syntax of how array lists are printed out. It's going to be square brackets. 10, 9, 8, 7, minus 15. That's how that's going to be printed. When I use cross out the code block in the tracing tool, it crosses out the remainder of the stack frame, not just the for loop. What do you mean? So when we create a code block and cross it out, it'll cross out to the bottom of the stack frame, but when I create a new variable, it's going to create it below that stack frame, or below that code block, is the way it should work. And if you're going here, you might be going cross out here. This will cross out the entire stack frame. So make sure you're hitting the right button also. The crossing out a code block button is going to be right here. Cross out this code block. So hopefully somewhere in there I answered your question. But if not, let me know. So we have two variables that refer to the same object on the heap. Then we're going to call this sum method. We're going to see the other side of that. Create new variable result. So we have some place for our return arrow for our new stack frame. New stack frame sum. Mark is returning to result. And then I'll answer some questions before I do. Actually, let me at least get it on screen. Input. Same thing as our assigned by reference. We're going to see what's called pass by reference or pass by value, but the value is a reference. Input is going to get that value OX02. Input equals my array. My array has the value 002. 002 is what's passed to the input. Not a copy of the array list, but a copy of the reference to the array list. Generally, it's okay to assign a new new variable, the two different variable. One is primitive type and one is an object type, except in a return value. Just always use the primitive types. Java will take care of the conversion between like int and integer, but always use the primitive type unless it is a type parameter. Like right here, I can't use the primitive type. Like if I put the primitive type here, I can't do it because I'll get an error. So I would, if you're not sure, always use the primitive type, and wherever you get errors, change it to the autobox type. But to more closely answer your question, if I have integer here and I return that integer when I'm supposed to return an int, Java's going to auto-convert this integer into an int for me. So Java will do the conversions for me. But if we do it this way, I'm only doing the conversions when I'm getting things out of the array list and when I'm putting things in the array list. Those are the only times where I have to rely on that auto-conversion if I have primitives everywhere else. And for what it's worth, there is an actual reason to do that. I know I said I just always do that, but the object types, the class types, can take up more memory. It's more memory efficient to use the primitives, usually. The compilers these days, I think, take care of that anyway, but it can be more memory efficient to use the primitives. It doesn't do that for you, and that's the button you press? Oh, man. Oh, no. I'm not sure what to say about that one. Are you using a strange browser? Are you using Safari? Everything will break in Safari. Like, not, I don't mean like with the tracing tool. I mean the entire internet breaks if you use Safari. If you're using Safari, just don't. Just stop. Use a better browser. But if that's not the issue, then I'm not sure. That might end up being an office hour question because it's hard for me to visualize exactly what you mean. I assume what you mean is when you click cross out the stack frame or cross out the code block, it crosses out the whole stack frame. You are using, yeah, you are using Safari. Safari will break everything on the internet. For some reason, Apple refuses to make a good browser. I would, at the very least, for your traces, for your quizzes in your tracing practice, I wouldn't use Safari. I wouldn't use it for anything personally, but if it works for the rest of your life, that's fine. For things, well, do I word it like that? For things that matter, don't use Safari. Until Apple pulls their heads out of their asses and makes a decent browser, or just starts using Chromium. I do a lot of web development, and Safari is one of the banes of the existence of any web developer. Because your app will work great across all browsers, and somebody's like, well, I'm using Safari and it doesn't work. Or you test in Safari and you realize everything's broken because Safari does not follow the specs. They do their own thing. They don't care about standards and best practices or anything. They just don't care. I mean, it's Apple. They don't care. They're in their own world. I like Apple products. I use a MacBook Pro. That's my go-to device. But man, some decisions they make just really piss me off. Anyway, I went white with rage there. Hold on. Back to reality. Why does system.out.println print the values in the array and not a reference to the array? Java's smart enough to follow the reference. It'll go over to the object and call its toString method. Can you reference what line of code you're on in the trace from time to time? Oh, good. Yeah, good point. I'm used to doing this on slides where I have an arrow pointing to the exact line that I'm working on. I do lose that when I do it this way. I just called the sum method where we just got in this line and we're going into the sum method call. We assigned the arguments to the parameters and we're about to do int total equals 0 right now. But before that, I want to talk about this assignment. I guess I don't have much else to say, but input equals my array. That's going to be by reference as well. So that will be passed by reference. Works on Chrome? Awesome. So that will be an assigned by reference. Input gets a reference. So at this point in time, we have 3 variables all storing references to the same object on the heap. And we only have 1 object on the heap. Okay, and then total equals 0. Then you get to watch me do some math here. I equals 0. So let's create our code block for I equals 0. 0 less than input dot size. So we have input dot size. The size is 5, which I'm regretting putting so many values in this thing now. We gotta go through this loop 5 times. 0 less than 5 is true. So we're going to go total plus equals input dot get I, input dot get I, which is 0. So that'll be 10. So total, cross out 0, put 10. We get to the end of the loop, increment I, and let me kind of just rip through this loop. I equals 1, 10 plus 9, 19. I equals 2, 2 is 8, 19 plus 8 should be 27. I equals 3, 7, this should be 34. I equals 4. 4 is negative 15, should bring us to that 19. Looks like all my math checks out. I equals 5, and then 5 less than 5 is false, so we don't execute the loop when I equals 5. We go to the end of the loop and return total. So we're going to return total. Total is 19, so result gets 19. And we cross out the stack frame. And then print result. Hit the end of main. Main stack frame ends, program ends, everything's done. So the big thing here is references. Again, hopefully a review from 115, but it will come back in a major way this all semester. So 3 variables that ended up all referring to the same object. And in this method, if we made any changes to the array list in this method, those changes would be seen outside of the method after the method returns by both of these variables because they refer, again, to that same object. So this will give us another tool that we're going to start seeing next Thursday that normally, before references, before the heap, our only way to communicate across stack frames is through parameters being assigned the arguments and return values being returned back to the calling stack frame. Those are methods of communication across stack frames. But now that we have the heap, this is going to open up a new line of communication where a method can be called with a reference by being passed a reference, go over to the heap, modify the object for that reference, and then it doesn't even have to return anything. Back in the other stack frame, as long as we have references to that same object, we can see those changes. So we have another way of communicating through the heap, which helps us communicate across stack frames. And we're going to start seeing, starting next Thursday, we'll see a lot of methods that return void that are called for their side effects, and those side effects are going to be modifying objects on the heap. Should we cross out the code block and then the stack frame, or does it not matter? Oh, did I not? Oops, sorry. Yeah, I did that. I got excited and skipped a step. We got to cross out the code block and then cross out the stack frame. Should we cross out the code block and then the stack frame, or does it not matter? Can I just cross out the entire stack frame without crossing out the code block first? The order, I'll say this much, the order doesn't matter. Can I don't know if I can uncross out a stack frame, or sorry, code block. I can't uncross out that code block, but if you crossed out the stack frame and then went back and crossed out the code block later, during grading, we'll never know. Like, we would never be able to know that you did them in the wrong order. So it's not going to matter. As long as you come up with the correct final stack trace, we have no way of knowing if you did anything out of order. You should do things... Carleen, what's up? You should do things in the right order Mostly so you can keep track of what's going on. That's why, like, I didn't take I. There's a temptation to do 0, cross it out, 1, cross it out, 2, cross it out, 3, cross it out, 4, cross it out, 5, and then go and update total. There's a temptation to do things like that, but I recommend doing things in order so you don't lose your place instead. And it's less likely that you're going to make silly little mistakes that end up costing you, potentially an F in the course because you skipped some steps that were crucial to the grading process. You don't want to risk stuff like that. So I would do things in order. But if you do things out of order, we'll never know. As long as you're right. Be right. Gerline, for those of you who don't know yet, Gerline's one of the TAs of the course. And Gerline's going to add office hours on Tuesday and Wednesday. Yay. To get our homework coverage. I think I said that at the top of lecture, so I had to say it again today, just now, Gerline. Okay. And I rambled for a bit just now, so I assume you had time to ask questions about this example, and that everybody's good on this. But I'll keep an eye on chat, so if there are questions, I'll revisit. But we need to talk about hash maps. So new Java class hash map example. Just do it correctly. That's, yeah, for real though. Like, probably one of my biggest pet peeves is when I give advice in lecture or directly to a student's face sometimes in office hours, and they don't follow my advice, and then they have consequences because of that, and then they try to turn that into my problem. It happens way, way too often. So I don't care if you don't take my advice. It's advice for a reason. It's advice and not a requirement because you don't have to follow it. But if you don't follow my advice and then you end up failing the course, like, don't expect me to care. I might care. I might be sad or whatever, but, like, you're still going to fail. I'm not going to do anything about it. Even if I feel bad. But yeah, so if you don't follow my advice, you just better be right. I don't care if you follow my advice as long as you're right. But if you follow my advice and then you're wrong, then I might help you out. Like, then, I can definitely help you, do what I can to help you succeed. When I make the new class IntelliJ, it doesn't list the package line. Why is this? If you created a brand new project and you went into the source directory and clicked new class, then you won't have a package line because you're in what's called the default package, which is when you're right in your src directory. But when I created that class, I right-clicked on week 2 and went new class. Then it created it inside the week 2 directory, and since the package has to match the directory, IntelliJ is going to make sure that, okay, this is in the week 2 directory, you must mean the week 2 package, and it'll add my package declaration there for me. All right, hash map example, main. And I get to update my example from lecture. The lecture example is a little bit out of date. So I get to fix that here. So hash map, when we create a new hash map, we still have to do type parameters just like we did with the array list, and we can only store those types. Yeah, we will get mad if you... It's just so frustrating too. Because, like, when I give advice like that, I'm saying, look, I can see what's coming up. Like, I see this pit that you're about to fall into. Here's how you avoid it. And then some students just be like, screw you, professor, and then walk right into the pit. And it's just, as an educator, like, it's frustrating to see that. Like, what more can I do? But, if you're going to ignore me who's teaching you how to navigate this new landscape of programming, like, you're going to ignore me. What the fuck? Like, what am I supposed to do? There's nothing I can do at that point. That's why it's so frustrating. Like, why are you even paying me then at that point? Like, I don't get it. I don't get it. So we still have to do... type parameters, but it actually is plural now. We have 2 type parameters because we can have a different type for the keys and values. So here I'm going to create a hash map of string to integers, the way we would say this. So the keys of my hash map are going to be strings, and the values are going to be integers. And hash map is our dictionary in Python, our object in JavaScript. This hash map is our key value store. Order doesn't matter in these key value stores. All that matters is that we have keys mapped into values, and we can't access values by their index because there is no index. We access values by their keys. And we're going to do some bills players because that's what we have in the slides. Except we have Diggs in the slides, and Diggs is no longer with us. So we're not going to use Diggs in this example. And we do have to import this. IntelliJ was pretty good about auto-importing it. I didn't have to think about it or do anything. But we do have to import it. Hashmap is in the same package as ArrayList, but it'll be in the hashmap class, or the hashmap file to define the hashmap class. So we'll create this new hash map, and everything else is the same. This will create a new object on the heap and all that good stuff. And then to add to a hash map, it's not anything that makes sense. I think it would make most sense to do add. For some reason they call it put. Oops. Put to add a key value pair. We're going to add a key value pair. We're going to add Alan and his number to this hash map. And we're going to put no longer Diggs, but I don't know about y'all, but I'm excited about Coleman. And that's how we're going to add into a hash map. And if we want to get something out of a hash map, if we want to get Alan's number, I'll do it similar to how we did it in the slides. Alan's number is, we want to get something out of a hash map. Bills.get. It is still get on this side of things. So get by key. And what this should do is print out Alan's number is 17. The question that always comes up here is, what's the difference between print and print line? Print line is going to print and then add a new line character at the end of what's printed out, and print will not add that new line character. So if I want this all printed on one line, but I want to have two separate print statements to print that one line, I'm going to use print the first time to avoid the new line character, and then print line the second time to get that new line character. So put when we want to add a key value pair to a hash map, and the types, of course, have to match the types that you provided when you created the hash map. And then get is going to give you the value at a specific key. And then for what it's worth, I won't do this on a quiz, I don't think, but if we printed out a hash map, the syntax is going to be braces, and then key equals value. And the big thing to note here is that order does not matter in hash maps. You won't always get the hash map back in the same order in which you added the key value pairs. So we got Coleman, then Alan, even though we added Alan, then Coleman. The order can be different, and I'm happy it ended up being that way. I didn't test this one. That the order can be different. So on the quizzes, I'm never going to give you a situation where the order of iteration of a hash map is going to matter. You can iterate over them in any order that you want, and we're going to make sure that the result of the program isn't going to matter in that case. Can we have get inside the first print line? Yeah, we could have. I did that specifically just to show you the difference between print and print line, but we could easily do this. Like this would do the same thing. You should get the same exact output here. No change. But I did it this way just to show you something different. So the order, if on your quizzes, you iterate over them in the order in which they're inserted. That's what I always do. That's what I'll do in this memory diagram when we get to that part. If you do the same thing, that'll be perfectly fine. That's a good question. Should you add your imports manually or get in the habit of having IntelliJ add them for you? I like not typing that, but as you're getting used to it, it might help to type out your imports just so you absolutely know how your programs are supposed to work. But I would recommend a hybrid actually. Here's my advice is let IntelliJ do your imports for you and then get in the habit of double checking your imports. I think that's just kind of habitually what I end up doing when I'm coding. Let it do your import for you. If it doesn't do your import, like sometimes IntelliJ won't auto import. I don't know what the differences are, what causes that. Sometimes it won't do your imports for you. But when it does do your import for you, or let me show you that actually. So if it doesn't do your import for you, it'll have all these errors, and then you can Alt-Enter import class and have it import. So I would have it do your imports for you, but double check to make sure you got the right class. That's what I'm trying to say here. Make sure you got the right class. Make sure it's Java util hashmap. With hashmap, it's probably always going to be right. But there are cases throughout the semester where we'll create classes that match the names of classes that are internal to Java. And this is why we do imports to begin with. In Java, there are a lot of classes that exist. There are a lot of class names that are used. And if you create a class with the same name as something that exists in Java, we want to allow that. Like Java wants to let you do that. You're not expected to memorize every single class that exists in Java, so you avoid name conflicts that way. Sometimes you're just going to create classes that have the same name as something in Java. So when you use the auto import, sometimes, and you have a class with the same name as a class that already exists in Java, sometimes it'll import the Java class, sometimes it'll import your class, and depending on which one you want, you would have to double check that import and make sure you got the right one. Because if you have the wrong import, nothing's going to work the way you expect it. Especially when we get to like the comparator class. No, I thought I would get the right one. Oh, because we have the testing week. We won't have week 5 in the summer. But the comparator class, Java has a comparator class. So if in my class, oh no, I lost where we were. Say I want to create a comparator. And I just hit enter, I just got java.util comparator, not week 6 comparator. So I would have to manually change this to the week 6 comparator so I get the right class. So that's what I would get in the habit of doing. Let it import for you, but double check to make sure you got the right thing. Okay, for hash maps, the next question is how to iterate over these. And this is where I would normally introduce the for each loop, but we already talked about it a little bit. This is where we have to use a for each loop to be able to get the values of our hash map. We can't iterate over the indices because there are no indices. So we have to use something different, and there are a few different flavors of loops for a hash map. One, we can say for string key in bills.keyset. We can iterate over the keys using keyset. I'll just print out the key. Or we can iterate over the values. So we can say int, not integer. I'm always using primitives unless I'm forced to use the other type, the class type. Bills.values is going to iterate over just the values. Oops. And there is a third flavor. I'm not going to do it because I always forget the syntax off the top of my head. But there is entries. You can iterate over the entries, which gives you keys and values at the same time. I don't like memorizing things, and I always forget the syntax of entries, and it's different in every language, and Java syntax is non-intuitive in my opinion. So I don't use that one. But if you do want to iterate over the keys and values at the same time, for my money, this is what I do. I'll iterate over the keys, and then the first line of my loop, I'm going to get the value. I'm going to pull the value from that key. Let me just do a simple print statement here. This is what I like to do. I'll iterate over the keys, pull the value, and now I have access to both key and value simultaneously. And I don't have to memorize any extra syntax. I just remember things that are already easy enough to remember, that I already have in my arsenal. IntelliJ is very reliable when it comes to importing hash maps and array lists. Yeah, with these ones specifically. But as we get through the semester, as we get to the later stuff, like comparator, like I just showed, then it's going to start being a bit iffy. Once it has decisions to make, and most students who rely on auto-completion, they use auto-completion so they don't have to make decisions. And when IntelliJ makes the wrong decision, now all of a sudden I have a student who is too reliant on the tool, doesn't understand things, and then I have to teach them things that they should have learned in week one. So that's my caution about that. Make sure you don't rely too much on your tools, which is becoming a huge problem now that AI is getting so prominent. Now all of a sudden it's in a 300 level class where I'll have students who don't know anything at all, but they're getting to the point where their AI is getting to be useless because the assignments are too complex. And I find out that, holy shit, I have a junior that doesn't know shit. It's becoming a big problem, and I'm not sure what to do about that besides fail a bunch of students. It sucks. Don't do that. Don't rely on your tools, no matter what your tools are. In line 18, int values means the iterator of type int. So it could be, in theory, int v. Yeah, so I'm creating a variable named value. Yeah, if I want to name this v, this is a variable name, so I can name it whatever I want to. This is like my initialization in my regular for loops. This would be my, I'm declaring a variable of type int named value, and it's going to iterate over this data structure. It's going to get all the values in this data structure one at a time, which is the values of the hash map, which is 17 and 0. Which we'll see right now in the memory diagram. We're about to head over to memory. Oh, let's actually run this so we can see what the output's expected to be. So we're going to do our print statements we already saw. We're going to iterate over just the keys. So this is Coleman Allen. Just the values 0, 17. And again, the order is backwards from what we inserted. But that order is irrelevant to us. And then when we iterate over the keys and get the values and print out key colon value, Coleman 0, Allen 17. Why is the syntax colon and not inside the, and not equal inside the for statement? In OBS, they put this, like I can put emojis in the chat, but they put the emoji icon over the chat. So I have to really work hard to see that was the equal sign. I want to find a setting. I haven't found one in a quick search. But anyway, and not equal inside the statement. That's what the Java developers chose. I don't know. That's what they chose. It is like that in several other languages. And in Python, this was literally the word in. That's how you read the colon, is in. It's not strictly an assignment. It's an iteration. So I guess they wanted to use a different symbol to make that clear. For string key in bills.keyset is how this is read. Okay, let's trace it up. Get the right pixel, get the wrong pixel. Hey. Bigger this. I'm going to need a lot of I/O, but not so much heap space. So I think I'll put this right here. Okay, let's start with the main method, where we always start. Main bills, create a new hash map. So new hash map. That hash map got the value. I'm just going to use the defaults, which the tool will start at 002 and then increment by 1. So my next object would be 03, 04, etc. Delete. Just out of curiosity, 03. So use the next available. Okay. Then we're going to, new returns the reference, so 002. OX02 is what's stored in bills, just a reference. Put Alan, so bills dot put, that's called on this object. Alan 17, and then put Coleman 0. Print Alan's number is. Alan's number is 17. And then print bills. Again, even though I know, because we just ran it, that this will print Coleman, then Alan, I'm still going to do Alan, then Coleman. Equals 17, Coleman equals 0. And again, the syntax here, I'm not going to be picky about this. If you don't know the exact syntax of this, if you don't memorize exactly, I don't even know if I got it exact, to be honest. Oh, hey, I did. Okay. I did, but I could have got something off a little bit there. It's fine. I'm not going to be picky about that. And to be honest, I probably won't ever just flat out print a hash map on a quiz anyway. But if I do, I'm not going to be picky about the syntax. Same with the difference between print and print line. I'm not going to be picky about that. I'm doing it in this example just so the formatting ends up nice and to talk about the difference between the two. I'm not going to hold you accountable for that. I'm not going to, when it's pass-fail grading, I'm not going to fail you because of that. Like, it'd be ridiculous. If it was percentage-based grading, I would probably take off like -2 or something, and you get like a 98 if you didn't know the difference between print and print line. But when it's mastery-based learning like this, a lot of the little stuff like that, I have to let it slide, which I think is better, honestly. Okay, and then we get to this loop. Can you tell us what line of code is linked to the output on the trace? So Alan's number is where it's Alan's number is. And then print line bills.get Alan, this is what's printing the 17. That's on the same line as the previous one because this was print and not print line. And then print line bills, that's what's printing out the entire hash map, all the values. And now we're on the loop right here. Okay, so we get to a code block. In the for loops, the iteration variables in the for loops are created in the code block of that loop. We're iterating over the key set, so we're iterating over Alan and Coleman. So this will get, I know when this code is actually ran on the JVM, it's going to be Coleman, then Alan. But for our memory diagrams, the order's not going to matter. I'm not testing your ability to memorize the orders of strings and hash maps. Like, that's just not what we're here for. So if you always do it in the order in which they're inserted, that's fine. If you do it in the opposite order, that's fine too. I'm not going to care about order because it's irrelevant for our purposes. The quizzes are just traces, right? Or is it multiple choice or concepts? Nope, it's just traces. So this is what I'm doing right now is literally what you'll be doing on a quiz. It'll be assessing different things because we'll be assessing OOP and data structures on the quizzes. But you'll get code like this, and you'll go through this tool, generate your trace, and there will be a submit button. I'm in practice mode, so there's no submit button. There'll be a submit button. You do your trace, you click submit, And that's your quiz. So it's exactly the same structure of what I'm doing here. So key Alan, print key Alan. And we're iterating over this key set, which is Alan and Coleman. So cross this out. We get Coleman. Print that to the screen. And then cross out the code block. We get to the next block, int value, so we get a code block with value. And now we're iterating over just the values, so 17 and 0 are the values we're iterating over. 17, print 17 to the screen. Get to the end of the loop, we go to the next value in the data structure we're iterating over, which is 0. Print 0 to the screen. We've gotten to the end of the loop. We go to the next value. Oops, wrong loop. Got to the end of the loop. We go to the next value in the data structure, which we're already at the last value, which means we're at the end of the loop, and we move on with the code. This loop is gone. Key and value are both no longer in memory, and this is one case where that's going to be very important because in the next loop, I'm reusing these variable names. I'm iterating over the keys again, just like we just did. And I'm going to access the values at each key. So the value, 17, I'm getting the value at Alan. I'm reusing the variable names key and value, but since this key and value, these ones from earlier, are no longer in memory, there's no name conflict. I would normally get an issue if I create two variables of the same name. I'm redeclaring a variable with the same name. Java will not run that code. It'll be a compiler error. But since key and value are no longer in memory because they were in different code blocks, I can reuse these values, these names of these variables, which is why I purposely used key and value again, just to make that point. I can reuse these variable names. Then print key colon value. Alan 17. Get to the other the next iteration of the loop. Coleman 0. That's the end of the loop, and that's the end of the program. And I've really got to adjust this lecture. For some reason, I thought this lecture was one 50-minute lecture of content. It took me two 50-minute lectures of content. We're at the hour and 40-minute mark, and we were, I think, at the hour and 30-minute mark, maybe hour 25. Took a little longer in this lecture. I got to work on my timing and pacing with this style. But luckily we have some slack time today that it didn't matter too much. But I am keeping an eye on that. But this is way too much content for one 50-minute lecture. But that's what I have allocated in the regular semesters. Then we always fall behind a bit, and then I play catch up. And we get caught up, and it's fine. OBS disconnected. Why? Okay, well, yeah, we're back. I just got a pop up in the corner of the screen that said OBS disconnected. I don't like that. I have stupid fast internet and a powerful desktop. Why the hell would I ever get disconnection issues? I'm blaming Windows for that. I'm blaming Microsoft. Should never have a disconnection issue. Okay, so if there are no questions, though, I'll move on to the next thing. Hello, student. I think the stream is fine now. I do have the stream open, like the live version of it open over here. So I see that we are back, or at least 10 seconds ago, we're back. Old student and alum dropping by to say you're one of the most favorite professors. Yeah, thank you. I'm on Tater. Thank you for the kind words. Happens. Looks good now. Okay. I don't like having issues like that because we shouldn't ever have issues like that. With my setup, everything should be fine. Just like we had audio issues in the morning. Like, we shouldn't have audio issues. I got a nice mic here. Spent decent money on it. Maybe what I consider decent money isn't decent money. I don't know. It's a Blue Yeti. It's like $150, $200 mic, I think. And sometimes it's just absolute crap. I had to mess with the configurations a bunch. Maybe it's user error. I just don't know how to use the thing, but I thought it would just be plug and play. Just plug it in and it works great. There shouldn't be a setting that's like, I shouldn't have a setting, an option on this thing that is absolute shit. Like, just don't give me that option. Don't give me that setting. I had to turn the knobs in all kinds of ways till it sounded good. Okay, anyway, the next thing I want to do is get you started on programming task 1. So I am going to jump ahead to unit testing. I'm just going to briefly explain a little bit, and then I'm going to go to the homework and talk about getting started, and I'll give away, a decent chunk of the solution, to be honest. And do everything you need to get started with programming task 1. With things moving so fast, I don't want us to sit idle too long. I do want to give you something to sink your teeth into and get working on. And I checked Autolab, like quite a few of you have already finished programming task 1. If that's not you and that sentence scares you, don't worry. I think a lot of those students are students who are retaking the course, so they've already seen the unit testing content, and they're able to get that just fine, and they're waiting for the later content. So don't get scared if that's the case. But I would start working on programming task 1 today, since I'm about to go through how to start it, because you don't want to get into the later tasks. Like, starting next Tuesday, it's a task per lecture, and it's going to be relentless, absolutely relentless. The tasks will not let up at all. So you don't want to get behind. If you start getting behind on task 1, and you start falling behind on the task where you're still working on task 1 when I'm lecturing about task 2, and now all of a sudden I'm working on task 3, but you're aiming for the final deadline of task 1, and now I've already lectured on task 4, and you've already missed the expected deadline of task 3, but you're still working on task 1. Like, you're never, ever, ever recovering from that. You can't recover from that. It goes way too fast. It's way too relentless. Aim for those expected deadlines and do not fall behind. The Yeti does that. Maybe I just got to learn how to use it then. Maybe I have to spend more money on a mic if I don't want to deal with problems like that. I had the gain up too high, but I had the gain up at 1/4. So I have the gain all the way down now. Fuck off. OBS. Why? No, it was the stream again. Why? OBS says drop frame 0. 4,000 kilobits a second. I'm streaming at 4 megs per second. CPU 15%, 60 frames per second. Like, all my diagnostics say everything is awesome. We'll limp through the rest of this lecture if we have to. We'll get through this. So we have these 2 imports. These are from an external library. The library is set up through Maven using a pom.xml file. So when you clone the repo, you'll see a pom.xml file, which for our purposes just says install JUnit into this project. As long as everything goes well with that pom.xml and Maven, this should be automatic. You should be able to write these import statements and everything just works absolutely fine. So if these imports do give you errors on these imports themselves, on the import statements, and says can't find org.junit.test or something like that, That means something went wrong with the pom.xml. Usually, if that happens, that's usually when a student can't figure out Git or refuses to install Git and decides to go to GitHub and copy and paste the code into a new project manually, and then they don't copy and paste the pom.xml, or they copy and paste the pom.xml but don't tell Maven that they did so, and it just doesn't link the project properly. That's where you could have issues like that. If you have Git and you clone the repo the way I expect you to, then everything should just be automatic with that. On Windows, you do have to install Git separately and tell IntelliJ where to find the Git installation, which can be a little bit of a pain if it doesn't find it automatically. But once you have that set up, you should be good to go on installing the library. And then you can create classes that are going to be your test classes. And in your test class, you're going to create your testing methods, which are public void methods. So they're public, you can access them from anywhere, but they are not static. These are our first non-static methods we're going to see in the entire semester, because the testing library just works through non-static methods. That's how it works. So we're not going to make them static, and we're not going to think too much about the difference right now, not until next Thursday. Void, test methods don't return anything. Test methods don't take any parameters. You can name the test methods whatever you want, and you have to annotate your test methods with the @test annotation. This is what we imported up here, is the annotation. We're going to annotate this as a test, so JUnit knows that we expect this method to be called as a test. Without the test annotation, JUnit is not going to run those tests, and your test just won't do anything. Inside your tests, you're going to use assert statements. I'm using assert true here. We're also going to use assert equals when I get to the code just now. We're going to say assert true. This is the simplest way to write a test case. And we have a test case in our test method that's going to say, if assert that this, whatever I give as an argument, is true. And here I'm testing this very simple method, add 5. It takes an input, adds 5, and returns that. So if add 5 of 2 equals 7, if this method did return 7, then this test case should pass. I want to make sure that when I give this method 2, it's going to add 5 successfully and return 7. If it does, this assert statement passes, or this test case passes. Assert true of add 5 to 5 equals 10, add 5 to 1 should equal 6. If all three of these test cases pass, then this test will pass this code. If any assert fails, the entire test will fail. So this is the structure and notation for our testing in Java using JUnit. This is what we use for all the programming tasks, and it's kind of the missing piece for task 1 at the moment. Not quite missing anymore. So let's go to task 1. Let's talk about what you're expected to do here. And start the project. We'll set it up, and specifically the testing I want to show. So for this, we're going to write 3 methods. We're going to test and implement 3 methods. Average, which takes an array list of doubles and returns the average of those doubles. Sum of digits, which is probably the hardest of these 3 methods. It's not too hard, but there are tricks to it. Sum of digits takes an int of arbitrary size and returns the sum of the digits. So 1 plus 2 plus 3. So 123 is the input. It's going to give us 6. 5 plus 7 is going to give us 12. 3 plus 6 is going to give us 9. And it does have to handle negative numbers as well. And then best key is going to take a hash map of strings to integers and return the key mapping to the highest value. So for example, if I have these 3 key value pairs, CSE maps to the highest value, so CSE should be the returned value. If the map is empty, return empty string. This is a string of length 0. I just use the quotes to denote that this is a string. And then the trickiest part of this one is if there are multiple correct answers, and this will be a theme throughout the semester. If there are multiple correct answers, then the correct solution can return any of the correct answers. So cat maps to 5, dog maps to 5. We have a tie for the highest value. So a correct solution can return either cat or dog. So when you're writing your code, you don't have to think about this too much. That's fine. But when you're writing your test cases, you have to think about this a bit more. Your test case needs to pass if the solution you're testing returns either cat or dog. So your test case needs to handle that situation. So for example, if your code returns cat on this input, and you write your test case, assert that the method returns cat, and then you submit that to Autolab, and your test runs against my correct solution, and my correct solution returns dog, your test is going to say that my correct solution is wrong, even though it returned a correct answer. So this really matters in your testing, that you need to accept either any of the correct answers in your testing. Okay, so to start the project, we would go to the repo. That's our first step. And it's the same repo for all 8 tasks. So you only have to do this once throughout the whole semester. But we're going to go to code, copy this link, go to IntelliJ, go to Git, clone, paste, and I'll get an error here because I already used this directory. You won't get the same error, but this directory already exists and it's not empty. Your directory will be empty unless you've retaken the course and already cloned this before, but in that case, you would just use your old project. Like, there's no reason to reclone it because nothing changed since last semester. But let's just give this a random number. 5647 looks good to me. And then clone it into that new directory, and that will download that project. We're going to see a bunch of progress bars that go too fast for us to really see what they're doing. But part of what happened there is it ran Maven. Maven looked at this pom.xml, which said download JUnit and link it to the project. And it did that. It got JUnit, linked it to the project, and now I don't have to worry about that external dependency at all. Where's the Git button on Mac? It should be... It depends. So it's on my Mac, it's in the same spot, but it depends on what version of IntelliJ you have. And they changed the interface in the newer versions. I still have the old interface. I should update that so I have the same thing you're going to be looking at. But if you see a VCS button, that'll be the right one for version control software. Git is version control software. So sometimes they use the acronym VCS instead of Git, and then there might be a Git submenu in your VCS menu, or you might be able to do. If I do this, I can get back to this. Git from VCS. If you're at the main splash page, you can do Git from VCS, and it'll take you right to where you paste the URL. I already cloned it, so I'm going to go back to my project here. And you have the starter code. We talked about this last time. I think I talked about it in both lectures. But the data structures directory you could ignore for now. That'll all be relevant in later tasks. For this task 1, it's the problem set class and the test problem set class. They're both set up for you. Test problem set has all the imports that you'll need. And let's start with problem set. I will strongly recommend throughout the whole semester to write your tests before your code, and the feedback in Autolab encourages you to do that. But there is a little bit we have to do with the code before we can do that. So we're going to call our methods from our test problem set to be able to test if they return the right thing. And average is already created for us. We want to do the same thing for other ones. This is what's called a stubbed out method. We created the method, but it just always returns some default value. So this method obviously doesn't do what it's supposed to do. It's not correct or anything, but it does exist, which is important. And we want to do that for the other two. The other two, I make you write your methods from scratch. And I give you quite a bit of dialogue in this. It's the same repo for all the tasks, so clearly I don't do that for any other task. But for task 1, to get you started, I want to give quite a bit of help. And all of these methods are going to be public static. If I spell it right. Public static. This one returns an int, not an integer. Takes an int. as a parameter and returns the sum of the digits of the input as an int. It says int right here. Some students will still have integer. I don't get it. I went on that rant for a while. Yeah, no, I did this lecture. I'm going to assume that they didn't write their own code because no human being can look at this, look at the word int, and then type integer. Like, you would never do that, ever. Like, why would you ever do that? Only if you're not writing your own code. Again, if there's a better explanation for that that is less malicious, let me know. But at this point, we need the name of the method here. And what I like to do is copy and paste this. I would copy and paste it, from here on this one. But I would go to the homework document and copy and paste those exact characters whenever the name matters so much in a way that IntelliJ is not going to catch a typo. So, for example, if you have a lowercase d here, and that's your method name, everything's going to work when you run it in your IntelliJ. Everything's going to be fine. But then when you submit to Autolab, you're going to get nothing but errors. It's going to be errors for days, and nothing's going to work. And you're going to come to office hours, and these are really frustrating office hour visits for the student. It doesn't bother me too much. It does bother me vicariously, but is the student will say, man, I've been working for hours and everything works fine for me in IntelliJ, but then when I submit to Autolab, I get nothing but I get errors for days, blah, blah, blah. And I've been working on this for hours. I've been tearing my hair out. I can't figure out what's going on. And I take one glance, and in like 2 seconds, I'm like, yo, that's a lowercase d. That's not the name of the method. You got to make a capital D. They put a capital D, submit to Autolab, and they get credit for the assignment, and everything's fine. And they're left so frustrated, like, oh my God, that was it. Just cut and paste the name. You'll never be in that situation. Scenario will never describe you, because I literally can't make a typo when I do that. Like, I didn't type anything. How can I make a typo? You'll never be in that situation if you cut and paste any of the names, all the names like that. So this takes an int input, and I'm going to stub this out, return 0, just some default value, just so this code compiles and I can call it. And same thing down here. Public static best key returns a string. And these words I don't mind typing, because if I type string wrong, I'm going to get an error. IntelliJ is going to tell me right away, flag me down, and say, hey, something's wrong. But IntelliJ is not going to tell me if I didn't capitalize my K on best key. Actually, it's a bad example because it does. It says, hey, something doesn't look right. But if I capitalize my B, it's not going to tell me that I made that mistake. Return some default value. This takes a hash map of string to integer. Let's call it input. It's going to flag me down for all of these things because these are types. I can't have typos there unless I make a typo so bad that it is another different valid type in Java. Input is your parameter name, and IntelliJ Autolab's not going to care what you name your parameters, your variables. But best key, this is where I would cut and paste, because nothing's going to catch my typo there except Autolab, and that's a frustrating error to find. It's hard to find that. Don't put yourself in that position. So now I have all three methods created. They're stubbed out. They're all wrong, of course, because I didn't even attempt to implement them, and I'm not going to give you those. But I do want to get you started on the testing, because that's the new thing in 116 is writing test. So when I write a test method, I want to make sure I have my test annotation. This is going to be public, but non-static, void, and test average. Takes no parameters. And that's my first test method. I'm going to create 3 test methods. You can break this down to more than 3, but I recommend at least doing 3 for this specific problem set. Test sum of digits. And I'll show you when we get to Autolab. I'll explain why. And test best key. And let's see how to set up a few of these test cases. I will give away some of these. Oh, something in the handout I wanted to point out. I want to make sure I say this one. This is not too bad of a pet peeve, but it is becoming a point of frustration, is when I give sample test cases like this, at the very least, code up these test cases. Like, code these test cases. Especially with average. I seen average just last semester. I had multiple students with the same issue. They coded up the first one and the last one because they knew they needed their edge case. 2 test cases. Didn't even bother doing the other 2 that I gave you for free. Gave these for free. They didn't even bother coding these up. And then they come to office hours and like, Autolab says I don't have enough testing. Like, what's going on with this? You didn't even do the free ones. Why are you talking to me? You didn't even do the ones I gave you. At least code up the ones that I give you. These aren't enough to satisfy Autolab completely, except best key I think might be. No, it's not quite. There's one that's missing. So each of these is missing at least one feature that needs to be tested. So you have to do more tests than this, but at a minimum, if you're coming to office hours, at least do the ones I gave you. I don't get that level of laziness. Not even laziness, because you're taking the time to go to office hours, but didn't even put the minimal amount of effort into it. Like, don't be like that. Don't be that student. But what I want to do, I'm only coding up the first one because I'm just showing you the structure of how to do this. Is I want to write a test case that's going to test my method. Now I already have problem set imported. All the imports that I'm going to need, actually not all of them, I'm going to use assert equals here, are here. So let's set up my array list of doubles. I'm going to call it numbers because I'm super creative like that. Array list. And then we want to, oh boy, I missed my new. And then numbers, to use what we've seen already in lecture, we could do numbers.add 1.0, 2.0, 3.0. And then what I want to do is call my method. I like to do this in 2 separate steps. I'll call my method. So double actual is what I actually got from the method call. That's going to be problem set.average numbers. And then what I expect to get. So my expected is going to be 2.0 in this case. And then I'm going to actually not use assert true. I'm going to use assert equals for reasons that I'll discuss at length on Tuesday. Assert equals expected. I hate these pop-ups. I don't need all that crap on my screen. And actual, and then a 0.001 some delta. When you're comparing doubles, you need some tolerance, some allowance, and that's what I'm doing here. But I'll talk about everything else not today, on Tuesday. We still need to do edge cases, right? Yeah, edge cases. Even a few of the edge cases I give you in my examples. But there are some edge cases I don't, some I do. You know, you just got to find out what the other things are. And I give hints in the Autolab feedback. We'll see that too. I'll show you exactly what I mean. For Mac, I noticed it only shows up when you create a project by uploading from GitHub. Hit the from VCS when making a new project. When you upload from, so when you upload to GitHub and share it, then the buttons appear. Oh, I see. So it's not linked to a GitHub project already, then you don't have the Git button. I see. And all the examples I show, I'm already in a repo that I've cloned from GitHub, so I wouldn't have come across that. So actually, let's test that right now. New project. Untitled 6 is a beautiful name. Yeah, and then I don't get a Git button, but I get a version control software button. I see. And then how would I do it here? Get from version control. Yeah, get from version control would do it. So it's a bit different. VCS, get from version control if you're already in a new project. And repository URL, get, and then paste your URL, which is not best key. Good call. Thanks for pointing that out. And this is my first test case. So I have a test case for test average. For test average specifically, I like to have a separate method for each one, because if I cut and paste this, I have to create a new variable for each one of these, and now I'm doing like numbers 2, 2, 2, 2, which is always painful. Or you can set things up in a different way, which I don't feel like explaining completely right now. Actually, I will in a minute. Partially, at least. Okay, but this is kind of tedious. What my big thing when I'm creating test cases and test methods and everything, testing in general, is I like to set up my tests in a way where I can add new test cases with minimal effort. When I add a new test case, I should be thinking of two things. What's the input that I'm testing and what's the expected output? And that's all I want to add. That's it. So I want things as clean as possible. I don't want to do this numbers.add, numbers.add, numbers.add. That gets tedious and annoying. So we can create an array list all in one line if we use arrays.asList. That's going to let us do 1.0, 2.0, 3.0, and initialize our array list just like we would in other languages, specifically Python. It's a bit more overhead, but we can get to the point where we can just specify a list of values and put all those values in our array list as we're creating it. But we have to call this arrays.asList, or somebody pointed out, I never used it before, but somebody pointed out in the other lecture, if we do list.as, does the same thing, and we have to import list. Oops. Wrong button. And Java got really confused on that one. Is it lists plural? Well, I forget what it is. Anyway, I use arrays.asList anyway. I forget what the syntax is, as someone pointed out in the other one. I thought it was list.add. But apparently not. It's not worth digging. We ended up digging through the code. Actually, I do want to say that. If you have any code, especially like Java code, and you're interested in how it works for whatever reason, if you do Control or Command, depending on if you're on Windows or Mac, and then click on it, I feel like I did just say this. We did, because we did the live coding earlier, we did this. But we can click on this, go to the as list, and see what it does. And I ended up doing that with both methods in the previous lecture, and they both did the same thing under the hood. So we got to the same functionality regardless. Will the Autolab feedback always let us know about the missing test cases that we should still do? It'll give you a list of features that need to be tested, and it'll tell you which features you've successfully tested and which features you didn't. So it'll tell you, hey, you still need to add a test case for this feature. So once you have your tests, once you have some tests written, you can run the tests. You have all kinds of go buttons around here. I like to right-click on the class and hit run. I mentioned that on Tuesday, but I didn't really say why. And this is one of the big reasons why. If you hit like this button right here, that's only going to run this method. So if you want to run just one of your methods, then you can use these individual buttons, or go to the class itself. This will run all of your tests. But I'm always paranoid that I'm going to click the wrong button and run one single test instead of all of them when I want to run them all. So because I did do that before, I wasted a bunch of time thinking I was passing my tests, but I was only running one of the tests in my test suite. So if I right-click the class and go to run, I don't have the option of messing it up. I'm preventing myself from making a mistake, just like the cut and pasting the names from earlier. I want to do everything I can to get my human error out of the equation. So anytime I have an opportunity to do that, because I've lost way too much time from my own human error in the past. So I'll right-click the class and run it there. And then once I run it once, I can start using this button up here. This will run the last thing that you've ran. It won't run necessarily the file that you're viewing. So be careful with this button, because if I ran my tests, and then I go to problem set and I want to write a main method to do some different analysis or whatever, I'm still going to be running the problem set, the test problem set. code when I do that. Okay, so all that, when we finally do run the test, I can see that I've failed my test average test, which I expected 2, but I actually got 0.0. Well, that's because my method... Oh, actually, I wanted to do that here. That's because if I control click, I can quickly go right to my method. My method always returns 0.0, so of course it wasn't going to pass this test. And when I use assert equals, it will give me some extra information. It'll give me what I expected versus what I actually got, tell me the difference between the two. And if you want extra information, I'm just going to slap something on there. If you want extra information here, you can add another argument. The first argument, if it's a string, it will print out that string when the test fails. So if you want extra information, it's called a type hint, or not type hint, oh my goodness. It's called a hint text, or apparently as Java, as this library calls it, just message. But I always call it hint text, because it gives you a hint as to where your bug came from, if you give yourself extra information there. Okay, with all that, let's go to test sum of digits. And for this, I want to copy and paste these test cases. And we'll code up these 3 test cases. And we could do this. Do assert true problem set dot best key 1 2 3 equals 6. And to be honest, best key, what am I doing? Sum of digits. Oh my. Sum of digits. And to be honest, this isn't even all that bad for this specific method. It takes ints, it returns ints. Ints are pretty easy to work with. We don't have any variables, so we don't have to worry about extra, renaming variable names. For example, if we cut and pasted this, how many times have you done this in your life? We want to create another test case. Maybe we want 1.5. Then you do numbers 2, actual 2, expected 2. And now you have your new test case, and you run it, and nothing's working the way you expect it to, because you have actual here instead of actual 2, and oops, I forgot 1, 2, and I just wasted an hour of my life trying to figure that out. That gets painful, so we want better ways of organizing this. One solution to that is just copy the whole thing, put a 2 right here, and then change your test case. That's a lot cleaner way to do it. Or what you can do is organize your test cases in a data structure. So this is my preferred way. As long as the method that I'm testing is conductive to this, I'll create a hash map of integer to integer in this case. My test cases equals new hash map, and then test cases dot put 1 2 3 6. It's a little cleaner. It's not even that much of a change for this specific method, because it's a pretty simple, straightforward method to test. But we can put our test cases in a hash map. Do what we just learned about hash maps. I'm going to iterate over the keys. Int, lowercase I, int, because I don't have to use the class type here. Int input in test cases key set. That'll give me all the keys. Int expected is going to be test cases dot get input. And then I can call the method that I'm testing. Expected, let me get my actual. Actual equals the method that I'm testing. Call it on the input. Then assert true expected equals actual. Now when I want to add more test cases, I want negative 73 is 10. I just add the test case to my data structure, and it's as little work as possible to add these new test cases to get more test cases running here. If I run my whole problem set, now I had test average and test sum of digits are both failing. But when sum of digits fails, it doesn't tell me anything. There's no information here. Before I talk about that, let me jump to test best key first. Test best key has no asserts. A test only fails if one of the asserts fails. A test with no asserts will always pass. So even though my code is completely broken, this test is just a worthless test. It doesn't test anything. So it does pass my code. Same as if I had just one test case where the expected value is empty string. Well, I'm going to pass that one too because my code always returns empty string. And we're not going to do test best key. We're not going to... Actually, there is one thing. Let me do it before I forget. If I do assert true and I want to accept either cat or dog, in Python you would use or, and I'm not going to give the whole syntax and all the method calls. You can fill in the rest. But or in Java, this is the one big thing I got to get in a lecture somewhere to make sure I always say it, is double pipe. So this is the key right above enter. Hold shift and hit that. That's going to give you your pipe. Two of those is going to be your logical or operation. So you want to do something like this. Assert true, the solution returned cat, or the solution returned dog. Either way, I want to accept that as a correct solution. Don't do assert true cat, assert true dog, because now you have this weird situation where you have to return both simultaneously. It gets into quantum stuff. It gets weird. Don't do that. But you want to have one assert that's going to say, if it's either one of those, then we're good. Okay, now, test sum of digits didn't give us any information here. It just said it failed. And here's where I would want to do something like change assert true to assert equals, and then change this from equals to commas. If I'm using assert equals, then I'm going to get a little more information. I'm going to get that actual versus expected that we had before. So expected 9, actual was 0. So it looks like it's probably this test case that's failing, but this is a hash map. So ordered, it doesn't matter. And this was, well, I know because my method's always returning 0. But this is the first test case that's being executed when this method's being tested. So I get more information here. And if I stuck with the first way I did things, where I was cut and pasting my assert method, it's going to be harder for me to make that change if I want to make a change to the way I'm testing things. Especially the next thing, I would like to know what the input is as well, so I can add my hint text to tell me what the input is. Then when a test case fails, I know what the exact input was as well. So it's going to give me more information. I like more information when I'm debugging. Input was -36. Now I know for sure it's this test case. Expected 9, actual was 0. I can even print up here, give me input up here, testing with input, add a little more context here. And now I can also verify that this is the first test case that's executing, because when I have my output, testing with input, -36, -36 failed. I didn't get any other outputs, any other print lines here. And as soon as one assert fails, the whole test shuts down and ends. So nothing else is executed. So I get my first test case, and that's it. Nothing else happens after that. If I get rid of my assert, we can see that in action. We can see that it'll print out, it'll pass the test because I'm not asserting anything, and it'll print out all my inputs. It'll go through all 4 of them. And nothing's being asserted, so they all, they all pass. But if you don't set up your test cases in a data structure like this, each one of those changes is going to be a real pain in the ass to do, especially printing out the input each time. Those are all going to be a pain to do. But once I have this structure, adding new test cases is no big deal, and changing the way I'm testing is no big deal. It's really easy to expand this thing. And we could even do the same thing up here. It's a bit more cumbersome to do, but we can have a hash map of array list of doubles to doubles and put all of our test cases in there. And then we don't have to worry about naming our variables and creating new test cases. We don't have to do numbers 2, actual 2, expected 2. We can do the same thing in a loop like we did down here and have it work just exactly the same way. Okay, and next thing, once we're ready to submit, we have our code. Like, we're not happy with this. I know this isn't going to... I didn't even attempt to complete the assignment here, of course. But once you are happy with your code, or at least if you're done with one phase of the project and you want to see how it's doing, how it's performing, maybe you just wrote your test average and you think you have enough testing for the average method and you want to check it out, there's no harm in submitting, doing a whole bunch of checkpoints throughout your work. But whenever you're ready, and IntelliJ keeps moving this button too. On my Mac, it's in Tools and Pack Entire Project or Pack Whole Project. Let me check just to make sure I'm saying the right thing. Tools, Pack the Whole Project is what it's called. On this Windows machine, I don't know why they keep moving this. It's different in different versions and different OSs. But in mine, it's File, Export, Project to Zip file. And that's going to create a zip file for my entire project. I'm going to put it in my Downloads directory. And I'm going to make sure I know where it is and what it's called. That's very important to know what your zip file is, because once we export that, we're going to go to Autolab, go to task 1. Yeah, good question. So I got it auto-imported. As soon as I did assert equals, it auto-imported the right thing, and I didn't double-check the import like I just advised, because it always, for this specific instance, I know it grabs the right one. And everything was working as I expected to as well. But it did auto-import it for me. Alternatively, when you just have assert true, you can change this to a star and just import every assert that you would ever want. Just import them all. This is a wildcard that says, give me everything in this. This is a static import. I'll talk about this on Tuesday, but it's a static import. We're importing static methods from a class. So from the assert class, import all of the static methods is what this says. Do you need to download a zip file package? Maybe. So it's different all the time. So usually it's pre-installed with the default IntelliJ, but sometimes I've seen that it wasn't, but it's weird. If you have issues with it, come to office hours, we can get it sorted out. Because it's too different for every, I don't know why IntelliJ, it's like they keep changing at every version, I feel like. It gets frustrating. But anyway, once you do finally have a zip file, and I do recommend doing it through IntelliJ, especially if you have a Mac. Mac really likes to mess up the zip files if you make them through Finder. But once you do have your zip file, find the zip file, make sure you have the right one. This is the right one. I'm going to affirm that I did not cheat. Submit this, and we'll see what Autolab says. You'll get this submissions page, and this is where students treat this as a mashing simulator. They're going to refresh until they got their score. And I did not complete this assignment. Once you get a 1.0 submission, that means you've completed the assignment and you're good to go. You're done with that task. I got a 0, so I want to see the feedback and see what I did wrong. And this is going to be done in 3 phases. I'm going to run your tests on a correct solution, run your test for feature coverage, check your test for feature coverage, and run my test on your solution. So let's see what these 3 phases look in Autolab. And first, checking your test for correctness. For this, I'm going to take your tests and run your tests against my correct solution in Autolab. So I have your tests and my solution, and your code. That's what you submitted. I'm going to pull your code out of there and replace it with my code and run your tests against my code. And if your tests fail my correct solution, it's going to tell you right here. It's going to say, hey, something's wrong. You failed a correct solution. Fix your stuff. For task 1, this will often be with best key. If you're not handling the cat and dog situation, if you're not handling that correct, that's one of the only reasons you'll get not past this phase in task 1. And this is where I recommend that you split your testing into multiple methods, because Autolab will give you feedback on each method, and you can tell which one has the issue. If you are good on a correct solution, you'll move on to the next phase. If you're bad on any phase, it won't show you feedback on the next phase. If you're good on the correct solution, then it's going to check your test for coverage, and it's going to give you a list of features. Average on a large list, we only had one test case, and it was a list of size 3. I'm not specifying how big a large list is on purpose, so we need a bigger list for our method. And we failed this one, so we get the sad face, and it says you need to test this feature. At least one test case for each feature. You only need one test case to expose a feature, but none of the test cases expose this feature. Average of a list with only one element. Our one test case had 3 elements, so of course we don't expect to get this. We got sad faces on all of these. Some of digits with negative inputs, some of digits large numbers, some of digits edge case. Oh yeah, we didn't test any of these, did we? Yeah, we didn't do tests for any of those. No, we did some of digits with negative input. Okay, so some did go a little weird here actually, which is good because that's the next thing I want to show. We're 1 minute over. I lost time a little bit, but I want to show this. Oh, because I submitted with this commented out. So this will happen sometimes. My code is good there, but when I exported, it didn't take all the newest changes yet. So the best thing to do with this is go to File, Save All before you export. I've only seen this on Windows for what it's worth. Windows, the timing gets weird. I'm going to replace my old zip file. But to identify issues like that, you can view your submission in Autolab and make sure the code matches what you expect to have, what you expect in there. And let's submit this again quickly, and then I'll shut down the stream, get ready for office hours. So with this, I should have some smiley faces here. Some of digits with negative input, we do have this one tested, so we get a smiley face here. So we do have one of the features tested. And then when you have a fully correct solution, it'll give you the same feedback here. If you get all smiley faces, you got all the features. Once you get past that, you'll see phase 3, which I have a little bit different format, not intentionally. But phase 3 is my test running against your code. So you'll see these same exact test names here, and hopefully show that you passed all of my tests. For task 1, this is pretty much free. If you have tests that are good enough to get through this, and your code is passing on your own tests, then you're almost guaranteed to get this passed as well. This shouldn't be any extra work once you get to this phase, as long as you are running your own tests against your own code and making sure they all pass. Okay, I went 3 minutes over, so I gotta cut this out. 2.5 hours, and I still want to keep talking. All right, take care, everyone. I'll see you on Tuesday. Have a great weekend, and I will be going to office hours at 2 o'clock. Some of you, I'll see you there. If I don't see you there, I'll see you next